Welcome back, everyone. I hope I'm audible and visible. Please give me a thumbs up if I'm audible and visible. All right, great. So let's move forward. We had started with our discussion on renewable energy, and in that, we had discussed about solar energy and wind energy. Moving on to the next topic, the next energy source is geothermal energy. Now, when it comes to geothermal energy, first and foremost, understand what we mean by it. The word will give you a hint: geothermal. So, when do we use the word geo? When do we use the word geo? In the context of the earth, correct? So, in the context of the earth, we use the term geo. And then the second term is thermal. So, thermal means what? Heat. We just discussed in solar energy as well, meaning that this is an energy source where we are using the heat from inside the earth as a source of energy. So hence geothermal. Now, where are we getting this geothermal energy from? There are two basic ways in which geothermal energy is we can get. So one, it is basically the heat from when the planet was formed and accreted, and that heat which is there at the core, because as you go down the earth from the crust to the mantle to the core, you'll see that the temperature of the earth keeps on increasing, and this temperature, the high temperature that we have at the core of the earth, this is basically something uh, that that can be utilized, because sometimes what happens is that this heat that is trapped at the core can come to the surface with some fractures or maybe some kind of gap that sometimes happens. So that will become geothermal energy. And decay of radioactive elements can also lead to geothermal energy. What exactly do we mean by this radioactive elements? We'll have a discussion on it. But understand this, that when it comes to geothermal energy, these are the two sources that we have. First, heat from when the planet was formed, the heat that we have at the core of the earth, that is one source. And the second source is the decay of radioactive elements, correct? So these are the two ways in which we can get geothermal energy. So generally speaking, we see that there are certain geothermal energy reservoirs, and these reservoirs are where from we can extract this energy. So for example, the geysers, the boiling mud pots, the volcanoes, the hot springs, all these things, they are basically a part of the geothermal energy reservoirs. So as you can see in the picture here, that these are areas from where we can extract this energy. So that becomes the geothermal energy reservoirs. So overall, what we see is that there are three ways in which geothermal energy power plants are used. There are three types of power plants that can extract geothermal energy. First is called as dry steam power plant. Second one is called as flash steam power plant. And the third one is binary cycle plants. So what exactly are these three? Let's try to understand and see them one by one. First one is dry steam power plant. Now, in case of dry steam power plant, this is a way in which we see that all the heat that we get from inside the earth, that heat will be used for electricity generation. How exactly do we do that? Wherever you have this steam, wherever you have this buildup of hot springs, etc., you'll see that from there on, the heat buildup that has happened there, that heat will be taken up. All right, that heat will be taken up, and heat from this heat which is in the form of steam will go to the turbine, and this will help in the rotation of the turbines, where from we can produce electricity. So electricity will get from here. Now, this is the same Rankine cycle that we had discussed in coal, that from the boiler, the steam goes to the turbine. So here also, from inside the earth, the steam goes to the turbine. From there on, we see that there is a condenser that will be using here. There will be condenser that will use here, and this condenser will again convert this steam into water. And then this water again will be piped back to the source, from where on again we'll see that the same cycle will continue. That will again see that this water again, as soon as it goes to the reservoir, gets heated up, converts into steam, again use it back. So in this manner, this dry steam power plant has a very simple cycle that we use, that steam will go to the turbine, rotation, electricity, condenser, water, and again to the reservoir. So this is what we'll use. So that's why if you see, they work by piping hot steam from underground reservoirs directly into turbines from geothermal reservoirs, which power the generators to provide electricity. After powering the turbines, the steam condenses into water and is piped back into the earth via injection well. So in this manner, we see that this entire cycle would run. This is called as the dry steam power plant. Now, this dry steam power plant has been, you can say, uh, one of the first geothermal power plants that we had started using. But then we moved on to some of the better designs, more efficient designs. And this is where we have the flash steam power plants. Now, in case of flash steam power plants, there is this little difference between how dry steam works versus flash steam works. Now, first and foremost, in case of flash steam power plants, we see that the heat that we are getting from inside the earth, this heat will this heat basically will be in liquid state. Basically, water will be in the liquid state instead of being steam, because we have this part at high pressure. We have this part at high pressure. So at high pressure, what we see is that uh, water can still remain in its liquid state even at high temperature. So for example, let me just give you an instance here, that let's say you have water. Generally water will boil at 100 degrees Celsius, right, under normal conditions. But if you have very high pressure, let's say you have a higher pressure than usual atmospheric pressure, then in that case, even if you are 120 degrees Celsius, 150 degrees Celsius, even then you can maintain the liquid state of water if the pressure is high. Same goes here. The pressure here from inside is high. So because of this, what happens is that you still have it in water state, liquid state. And then it is carried to this part, which is called as the flash tank. This part is called as the flash tank. And when this is carried to the flash tank, this is where we see that all of a sudden there will be a conversion from liquid water to steam. Why? Because this flash tank is at normal temperature and pressure. So because it's at normal temperature and pressure, all of a sudden there is a pressure difference, that you had this liquid water at very high pressure, and now you have come to the vessel which is at normal pressure. So all of a sudden what it does it that it simply converts into steam very quickly as soon as we see a transition from high pressure to normal pressure. So this process of quickly converting from water into steam is called as flashing. This is called as flashing into steam. So that is basically what we see in case of flash steam power plants. That flash steam power plants, the hot water at high pressure from below the earth will come to the flash tank on the surface, and this flash tank uh, will cause the liquid, the fluid, to quickly flash into steam or quickly convert into steam. So much lower pressure and temperature. Let me add this also. Let much lower pressure and temperature. So this is what we'll see with flash steam power plant. Now what we have seen is that flash steam power plant has a better efficiency as compared to dry steam power plants. So that's why you'll see that off late, whatever new developments happen, whenever new power plants are being set up, you'll find that normally they are avoiding dry steam power plant and trying to move towards these kind of power plants. One more power plant which is very essential is binary cycle plant. Now, in case of a binary cycle plant, this is a design which uses two cycles at the same time. All right, it uses two cycles at the same time. That's why binary cycle. How exactly? One cycle is running from inside the earth. All right, this is one cycle of steam, correct? You have this steam. So in this case, what happens is that the steam that is coming from inside the earth, it directly does not go to the flash tank or does not directly go to the turbine, which is the case in, let's say, dry steam power plant, where this steam was directly going to the turbine. But here what we see is that this steam maintains its own cycle, and there is a second liquid with a second cycle that is working, which basically would be an organic liquid. So you have a second cycle that is running here. You have a second cycle that is running here. So one cycle is this, and this is the second cycle. So that's why this is called as a binary cycle plant, that there are two parallel cycles which are running in these scenarios. Now in this scenario, what happens is, and why binary cycle, why are we complicating the things further, why are we complicating this entire design? The complication of the design also comes with its merits, and the merit is its efficiency. That efficiency of binary cycle plant, efficiency meaning efficiency of conversion of steam into required energy. So this efficiency of conversion is even better as compared to flash steam power plants. Not only that, so this second liquid that we have is an organic liquid. So this organic liquid, if you remember, we discussed in fractional distillation that organic liquids would boil at much lower temperature, correct? So that's why if this second liquid comes in contact with steam, obviously it is coming in contact with high temperature, so it very quickly will simply convert into its vapor form, its gaseous form, correct? And because and there will be liquids like isobutene. So isobutene is used, or sometimes pentane is also used, isopentane is used. So there are all these, which will be all these liquids that can be used here. Now, apart from the fact that fine, it has a very good efficiency, great, but there is one more advantage, and this is a very unique advantage. There was a report that was published by IPCC. Can you tell me what is IPCC? Anyone quickly? What do we mean by IPCC? What is the role of IPCC? Yes, Intergovernmental Panel for Climate Change. Perfect. And what is the role of this IPCC? What does it do? Yes, report for climate change panel, correct. So it's not international panel, it's intergovernmental panel. So just a small correction that some of you have written. Giving assessment report on climate change, perfectly correct. Great. So you are correct. The answers that you've given, that's correct. So this is Intergovernmental Panel on Climate Change. What is the role of this panel? That they would publish scientific reports on climate change, understanding the patterns of climate change, understanding the geography, the geology, the science behind whatever is happening and why it is happening. So it's a perfectly scientific report that tries to understand what is happening, what was the past, what is the present, and what could be the future. And it brings out something which is very very important also, perhaps for your examination, called as the assessment reports. Very recently, last year, they have come out with the sixth assessment report. And these assessment reports are important because they are published not every year, but once in a while. The fifth assessment report had come back in 2014. And after 2014, 8 years later, with all the exhaustive research, they have come out with the sixth assessment report, which I believe personally is going to be very, very essential for anyone who's going to write the mains examination this year. I am very sure that we'll get something uh, from there. So that's why what we see is that the assessment report that they publish, there are various panels, there are various work groups that they form, and those work groups will submit the report to them, and they would finally publish the report. Now this IPCC had come out with a report on all the renewable energy sources a few years back, and when they assessed all the renewable energy sources that we are using today, it had noted there that out of all the renewable energy sources, the cleanest renewable energy source is binary cycle plant. All right. So even compared to solar energy, compared to wind energy, compared to any other renewable energy that the world is using right now, binary cycle plant, when used, is the cleanest source of renewable energy according to a report published by IPCC. So that also made binary cycle plant even more important, that it got to the notice that okay fine, this is the cycle that we are using here, this cycle actually makes it the cleanest source of energy. All right. So binary cycle plants, basically, the according to IPCC report, It's the cleanest source of energy. It's the cleanest source of energy. So that's why binary cycle plants became very, very crucial. So what is happening? That there is one cycle running off steam, which is generating all the heat, which carries the heat basically, comes in contact with the second liquid, that is isobutene or pentane or isopentane, butane, all these possible. So as soon as they come in contact, steam would, because of its heat, will just heat up the organic liquid, and ultimately we'll see that rotation of turbine will happen, and this will lead to electricity generation. So this is basically what happens in case of a binary cycle plant. Now, so these are three ways in which geothermal energy can be utilized. Now, when it comes to geothermal energy in India, there are certain areas that we have also identified in India, that these are the areas where there are higher chances of us being able to utilize geothermal energy from. And that's why these are the areas that become very essential for India's energy future. For example, if you consider Puga Valley, for example, Manikaran, for example, these are areas where there are hot springs, and these hot springs can become a source of geothermal energy. So all these areas that have been marked here, these are the areas where we see that geothermal energy reservoirs in India are present. Now, in this particular scenario, when it comes to geothermal energy in India, we see that there are certain steps that are being taken in India as well, and there are things that government of India is doing, and there are things that, in general, some of the international companies are also making some effort. Overall, as per the research, as per the study that has been done for by Geological Survey of India, there is a capacity of up to 10 gigawatt of power in India. And overall, there are 340 geothermal hot springs in the country that can become potential sites or sources for geothermal energy. At the same time, there are places that have been identified. We saw the Himalayan region, the Himalayan belt, plus some of the areas in the central India also. We can actually use them for geothermal energy. Now, in general, what we see is that geothermal energy is found largely along the tectonic lines. If you look at the map of the world and all the areas in the world where you have a presence of geothermal energy, you'll find that largely the presence is along the fracture lines, along the tectonic lines. So that's why in India also the tectonic lines run along the Himalayas, correct? They run along the Himalayas. So that is why that's the area, whether in Ladakh or whether in Himachal Pradesh or even in the northeastern states, you'll find that in all these areas, these are the areas where, so Sikkim also, for example, Arunachal Pradesh, for example, even parts of Assam, for example. So these are the areas where we find that there are higher chances for us to tap this geothermal energy. So there are few things that have happened. For example, ONGC a couple of years back had signed an MOU with Ladakh to develop India's first geothermal power plant, and this basically is being done at the Puga Valley. This is being done at the Puga Valley. Now, this plant that is being set up will be a very small plant. Just 1 or 2 megawatt will be the capacity. It will be a small plant. But this small plant, even this plant that they are building here, this will help in localization of energy. That because these are areas which are dependent only on solar energy, thermal electricity is not easy to transmit to these areas. So that's why this geothermal energy setup that we are doing here, this will help at least these kind of areas which are very highly remote in nature. These kind of areas can get electricity from geothermal. So that's why this will help in at least local generation of electricity. At the same time, we saw that last year Geothermal Corps of Texas signed a letter of intent to invest rupees 820 crores in Uttar Pradesh as well. So that's why there are all these efforts. We see that there are all these things. For example, there is another country from Iceland. Now, Iceland has a lot of active volcanoes. So that's why they have all these areas where geothermal energy is very easy to use. And that's why Iceland has been one of the leading countries when it comes to geothermal energy. So there is an Iceland based company, Reykjavik Global, which is also coming to India. and they also want to build a plant in India. So they have marked some areas in Andhra Pradesh, some areas in Chhattisgarh, and these are the areas where they have shown an interest in building a power plant, a geothermal energy power plant in India. So that's why we see that there are all these developments that have been happening in India, and we have been trying to understand how to tap geothermal energy better. So overall, when it comes to the advantages of geothermal energy, first and foremost, it is a renewable and sustainable source. And again, most of these points that we have are self-explanatory points. Renewable and sustainable, environmentally friendly. It's a constant supply, and this is one advantage over even solar and wind energy. Because solar energy also we discussed that it's a daylight only solution. Wind energy also, the problem is that there is a fluctuation in wind which can hamper the generation of electricity. But when it comes to geothermal energy has a constant supply from inside the earth. So the generation or the production can keep on happening 24 hours a day. So that's why it has an advantage from that perspective. So overall, that's why this is there. Then it also has a small footprint, because the setup that will happen will first of all happen in areas which anyway are not agriculturally suitable. Also, the fact that the setups are generally done underground, so that's why it will have not a big impact as the problem was with solar energy. Then it is going to be cost effective. Again, the return on investment basically is going to be good. Low maintenance requirements, low noise, reduces fossil fuel dependency, and increases energy security, job creation, and of course, it has a huge potential, because these are energy sources that India has just started to work upon. So that's why the industry is only going to grow and the opportunities are only going to rise. So that's why it will definitely create scenarios where more and more employment opportunities could be generated. Then, if we look at the limitations, the problems, first and foremost, there are geographical limitations. As we discussed, that there are certain areas in the world which have higher uh, energy probability, possibility. Not everywhere, not like solar energy. Large investment is needed to identify the areas, to identify the sustainability of the areas. So, all these kind of problems also have been there with regards to geothermal energy. Then after that, there are chances of environmental impact as well. Although until now we haven't really seen anything like that, that it might have an environmental impact, but we do see that there are chances that it might lead to these kind of environmental impacts as well in the future. So for example, there are chances that gases like hydrogen sulfide gas may be emitted from here. So then in that case, it's an air pollutant. Sustainability concerns, this is a very major thing, especially when it comes to the initial setup. We also see whether or not the source that we are trying to use, is the source sustainable, is the source going to last long. So all these things are also very very crucial to understand the viability of a long term arrangement with regards to geothermal energy. And then lastly, seismic instability. Now, in case of seismic instability, what we understand is that there are chances, because you ultimately are, again, most of these plants will be set up in areas which are near the tectonic lines. So when you start trying to get energy from these kind of sources, it might so happen that it might induce seismic activities leading to small scale earthquakes. This actually has happened in the past. There have been a couple of cases. For example, there was one case in Basel in Switzerland, and there was another case in the US. In these two cases, there was a small earthquake that happened in these areas. On the Richter scale, it was very low, like 3.7 or 3.8 near abouts. But then, when the research about the epicenter of these earthquakes was being done, they found that the epicenter was a geothermal energy power plant. So that's why we understand that there are seismic concerns that something like this can create. All right. So that's why there are certain limitations that we have with geothermal energy as of now. And we are only trying to improve. We are trying to be better in these kind of scenarios so that we can do a better job in the coming days. So although it is not a part of the target that we have kept for others. So that's why there is no 10 gigawatt target or 5 gigawatt target that we have for geothermal energy. Right now, there are only pilot projects being taken all across the country. There are several private companies plus some government companies. For example, ONGC is actively involved. So apart from ONGC, there are others also which are trying to step in into this particular segment, because it's just a new segment that has just started, and that's why many of the companies, they want to tap the into the potential of geothermal energy. And India is also trying to collaborate with some of the foreign countries, and especially the countries that have the expertise in terms of geothermal energy, so that they can help India in the growth story of geothermal energy. So this is about geothermal energy. The next one is bioenergy. But before going there, if you have any doubts with regards to whatever we discussed, please let me know. IPCC full form, as I told you, Intergovernmental Panel on Climate Change. This is the full form of IPCC. They didn't research by their own, only study and asset. Yeah, assess. Yes, that's correct. That their major role is to study and assess and collect the data from everywhere that they have, and then they publish the report based on all the data that they have collected and the various papers that have been published by maybe various scientists and researchers. Re-explain dry steam power plant. So the dry steam power plant, what we are simply saying is that whatever steam etc is coming from inside the earth, that steam will be directly taken into the turbine. Just imagine what we saw in the coal fired thermal power plant, that we were pumping water into the boiler, and because of the heat that was generated because of the combustion of coal, water converted into steam and was carried to the turbine. Here you don't have coal, so here you directly have the steam that is coming from inside the earth, and this steam basically, this heat energy that the steam has, this will be used up, all right, and goes to the turbine, leads to the rotation of turbine, and electricity is produced there. So this is basically what we do in case of dry steam power plant. All right, then moving on, the next topic for us is bioenergy. Now in case of bioenergy, what we mean, I mean, you understand bioenergy, meaning that this should be energy coming from biological sources. Hence, we are saying that this is bioenergy. Now, in case of bioenergy, we understand that this is energy of biological origin derived from biomass such as fuel wood, livestock, manure, municipal waste, energy crops, etc. Now, there are certain terms that will come across. Just try to understand all these terms. So the first thing is, of course, bioenergy, meaning that this is energy coming from a biological source. Then after that, the next term for us is biomass. So what is biomass? Biomass is the biological material derived from living or recently living organisms. So in the context for energy, this is often used to mean plant-based material, but biomass can equally apply to both animal and vegetable derived material, meaning that biomass is nothing but the biological material. All right, it's nothing but the biological material, and this is the biological material that you can get from anywhere. Anything that is biological, anything that is living, or anything that has been recently living, when you are deriving energy from there, you'll say that this is, or whenever you are deriving the biological material from there, you will say that this is nothing but biomass. All right, so this is where the concept of biomass comes from. So, so biological material, plant based or animal based, doesn't matter. Largely, it is plant based, whatever we use, but it can be animal based as well. So, yeah, Soumya, you have given the correct example here. The gobar gas plants basically are nothing but biomass, but we'll come to that example later. So, this is what we see with biomass. Now, this biomass will make up the bioenergy feedstock. When we say that something is feedstock, the meaning of feedstock is nothing but simple. raw material, right? The raw material that we'll use for bioenergy production, that will be called as feedstock. So in this manner, the feedstock could be again plant based or animal based. It could be a seed, it could be a fruit or a vegetable, it could be animal waste, it could be plant based waste, it could be anything. All right, so anything that we want to use as raw material for bioenergy production, so that will be called as bioenergy feedstock. Now, in this scenario, when we are looking at this bioenergy feedstock, one ultimately one when one comes to biofuels, let me just go through all these concepts once more, because all these are new words all of a sudden. I'm just throwing one word at a time for you. So we discussed that there is something called as bioenergy. Bioenergy. Then another term is biomass. Another term is feedstock. Another word is biofuel that you see right here on the screen right now. And we discussed one more thing, that was energy crop, that we derive bioenergy from energy crops. So let's understand again, what do we mean by all these terms? So bioenergy, what is bioenergy? Energy of biological source, hence bioenergy. Biomass, what is biomass? Biological material. What biological material? Plant based or animal based, something that is either living or has been recently living, will be called as biomass. What is feedstock? The biomass that we will use as the raw material for biofuel production will be called as feedstock. And then we have biofuel. So what is biofuel is what we are going to discuss. And energy crops. So energy crops are the crops that are good sources of carbohydrates. All right, these are good energy, or let's say carbohydrate sources. Good energy or carbohydrate sources, so these are called as energy crops. So ultimately all these basically lead to the biofuel production. Now what do we mean by biofuel? So we understand that fine, this is a this is a fuel that we are getting from biological sources. All right, that's why biofuel, because we are getting the fuel from biological sources. But I have a question here for you. All right, and I first want you to answer first, and then I'll build upon it. What is the difference then between biofuel versus fossil fuel? Can you tell me the differences? Ethanol blending we'll discuss in maybe next 15-20 minutes. We'll have a discussion on it. So biofuel versus fossil fuel. Okay, fossil fuel more production, more pollution, correct? Biofuel generation is quick, absolutely correct. Fossil fuel non-renewable, absolutely correct. Biofuels are carbohydrates and fossil fuels are hydrocarbons. Uh, Not exactly, but a very good line of thought. Fossil fuels take more time to generate, absolutely correct. So more or less, all of you have covered. Yes, cost is also a factor, perfectly fine. Cost is also a factor. Hmm. And biofuel from living or recently living organisms, correct, correct. All right. So more or less, every one of you have given the required points. So just to summarize, what we are saying is that in case of biofuel, first of all, it takes less time, and fossil fuel would take more time. And by less time, we just mean a few days, few weeks, or maybe a few months. That's it. On the other hand, we are talking about 250 million years and 360 million years. No, in this case, we are just saying that it would take like a couple of weeks to a couple of months time. So time is one major factor. Pollution is one major factor. That biofuel much less pollution, and fossil fuels highly polluting. Highly polluting. So that is the problem. So one is time, one is this. Then the third point can be that, as somebody had already mentioned also, that biofuel, you can say that it is renewable, and fossil fuels, of course, as we studied, are non-renewable. Correct. So that's that's another point. Then apart from that, we see that this is something uh, which from the perspective of, if one more thing if we consider, is the cost factor. Now cost factor wise, the things are opposite. The problem, so until now, the first 3 points, if you see, you understand that why biofuels have an advantage, that why do we want to use biofuel, is mainly because of all the issues that we see with fossil fuels. Correct. Now at the same time, there are certain issues. The issue first is the cost, that biofuels have higher cost and fossil fuels can be produced at lower cost. Fossil fuel at lower cost. And then one more problem is the technology or the ease of use. So this is here what we see is that production is difficult. Production, I'm hiding the thing, sorry. Production is difficult. Whereas in this case, the production is easy. So in this manner, we see that this is basically what the differences are between fossil fuel and biofuel. So from this perspective, when we look at, yeah, when we look at the biofuels, we understand that this is also a hydrocarbon based fuel. All right. So that also is hydrocarbon based fuel. And in this case, produced from organic matter, living or once living or recently living in a short span of time. Right. In a short span of time will be called as biofuel. Largely what we see is that there are three types of biofuel: bioethanol, biodiesel, and biogas. These are the three most important biofuels that is used worldwide, all across the world. So we'll try to understand what we mean by all these and how exactly are they different from one another, where are they exactly to be used, all these things we'll try to understand. Now, coming to biofuels first, the classification of biofuel, first of all, is done on the basis of generation. We call some biofuels as first generation biofuels, then second generation, then third generation, and then fourth generation. What exactly do we mean? Let's try to understand that. The first generation of biofuel is where we are actually getting the biofuel from food crops. All right. So they are basically derived from food crops. They are derived from food crops. So that is the thing. So now this becomes a problem, because the same food crops that are supposed to be for human consumption, they actually become the source for biofuel. So that is the problem that we have with the first generation biofuel. Now, another thing, when it comes to the first generation biofuel, they are relatively more polluting. Relatively more polluting compared to other generations. Compared to other generations, they are relatively more polluting. Then after that comes the second generation biofuel. Now, in case of second generation biofuel, first and foremost, we derive it from non-edible crops. All right. So source wise, the sources are either non-edible crops, non-edible crops, non-edible crops, or wastes. What kind of wastes? Both agricultural wastes or even municipal waste. Waste I already written, so I'm erasing this. Yeah. So that's why either non-edible crops or the waste, either agricultural waste or agricultural leftover or municipal waste as well, can act as a source for second generation. Now this also is relatively more polluting. Relatively more polluting compared to third and the fourth generations. All right. One more thing. One more thing is that generation of energy from second generation sources is not easy. Getting energy from second generation sources is not easy. And because of that, sometimes it is also called as advanced biofuel. All right. We also call it as advanced biofuel. Advanced biofuel. So why advanced biofuel? Advanced biofuel we are calling because not easy, not easy to generate energy from these sources. Not easy to generate energy from these sources. So this is basically why we also call it as advanced biofuel many a times. So this is the second generation. The third generation, the third generation is where we generally are looking for algae based biofuel. They are either algae based or there is something else which is called as bio CNG that in India has been named as the third generation biofuel. So either algae based or bio CNG. So this time it has an advantage that it is less polluting compared to first and the second stages or second generations. Then at the same time, energy production from here also is not that easy, but especially we need to understand or deep dive into the algae based biofuel. Algae based biofuel, because algae based biofuel has its own advantages. What exactly are the advantages? Just understand these. First and foremost, the algae basically they grow underwater. They grow underwater. So the advantage here, since the fact that they are growing underwater, the advantage here would be that they are not going to fight for resources. The problem with the first and the second generation especially also is that the same agricultural field also has to be used for food production. So now the land piece is limited. So either you will produce fuel or produce food. So food or fuel, and food versus fuel, it will start to happen. So it will cause a resource crunch. But that's not the case with algae because it is growing underwater. So there is no competition for resources. So no competition for land or water resources. So that is one advantage. One more advantage is they take less time to grow. They take less time to grow. Generally speaking, we know that any crop plant might perhaps take a couple of months time, and then the processes will begin. So then in that case what happens is that uh, a biofuel being derived from a crop plant might take up to 2 to 3 months, sometimes maybe a little lesser than that, sometimes maybe little more than that, but more or less 2 3 months it might take. Whereas when it comes to algae can grow within 1 or 2 weeks itself. So that's why within a couple of weeks, you will have the algae that you need for production to start. And hence we can use it quickly. So that's why energy production will happen much quicker in case of algae as compared to any food crop based plant. Then apart from that, one more advantage is that the efficiency is high. So let me write like this: per gram efficiency or per gram energy efficiency, per gram energy efficiency is higher. So meaning if you have 100 grams of a crop plant versus 100 grams of algae, then 100 grams of algae will give you more energy as compared to 100 grams of the crop plant. So that's again one advantage that algae based biofuel has. But then we should be using algae based biofuel. Why are we not using it? The problem is the technology. The implementation of technology that is required for algae based biofuel is not easy to implement. All right, it needs a lot of cost. So that's the first thing. So let me just write the negative points in another color. So the negative points, first of all, high cost of production. High cost of production, and then the technology is very complex. So these two factors, they basically are leading to this still being in a very nascent stage, that although experimentally we have been successful with algae, but ultimately we haven't been able to use it at a commercial scale. And to use it at a commercial scale will need a lot more of investment to happen, a lot more of research to happen, innovations to happen, so that we can actually lead these conditions can actually lead to a situation where we can make the use of all these things. So that's why algae still we haven't been able to use, although we understand the value and the advantages that we might have with algae whenever we are able to use it well. So that's basically what we see here. Now, apart from this, we also have the fourth generation. Now, when it comes to the fourth generation, this you can say that this is still in the experimental phase. This is in the experimental phase where we are just trying to figure out what the sources could be. All right. So there are multiple ways in which we define what our fourth generation biofuel could be. That one, it could be the second generation itself. It could be second generation with carbon sequestration. What is carbon sequestration, anyone? What do we mean by carbon sequestration? Can somebody answer this quickly? Absorbing the carbon dioxide from the atmosphere. Yes, you can say that. That's correct. Anyone else? Dating of carbon? No, dating of carbon, not exactly sequestration. Right. So carbon sequestration basically is the process. It is the process where we capture and store carbon dioxide. All right. This is related to capture and store carbon dioxide from the atmosphere. This is called as carbon sequestration. So now one can be that use the second generation biofuel, but whatever carbon dioxide, extra carbon dioxide is going to be released, just capture that, store it inside ground. So that will become, then it will become clean. So then it is called as, that is one of the researches happening with fourth generation. Another is to use genetically modified organisms that are specifically being prepared, genetically engineered, so that they can help in the production of biofuels. So that's why this is also one line of thought with regards to fourth generation. And then also we are looking towards certain microorganisms that can also be useful from the perspective of biofuel production. So that's why there are multiple ways in which we are looking at what can actually suit us as the next generation of biofuel. Then apart from that, overall what is expected out of the fourth generation is what is expected. So expected to be least polluting and the most efficient among all the four generations. So this is the basic idea, basic logic with which we are trying to design the fourth generation of biofuel. So this is basically how we define biofuel, that there are first generation, second generation, third generation, and fourth generation. Now, in all these cases, right now for all practical purposes, you can say more or less, we still rely on the first generation. And then some use of second generation has started happening over the past few years. So otherwise, world largely still is using the first generation biofuel itself. Now, to understand what the various different types of biofuel are, the very first two and the most important biofuels that we have been using are these two. One is biodiesel and the second one is bioethanol. So biodiesel and bioethanol, how exactly they function, just understand this, that biodiesel and bioethanol, uh, these are two sources of sorry, these are two types of biofuels that are the most widely used biofuels. So first is biodiesel. Understand what is biodiesel. Biodiesel is the biofuel that we derive from vegetable oils, basically the oil seeds. All the oil seeds, they can become the source for this kind of biofuel, that is biodiesel. So any kind of oil seed can be taken, and from there on, we can actually derive biodiesel. So these oil seeds will undergo a chemical process called as esterification, and after esterification, it will lead to the formation of biodiesel. And this biodiesel is something that can either be blended with or it can be used to replace diesel. All right. So either we can replace it or we can blend with diesel. So, for example, right now India has kept a target that we will soon start with 5% blending of biodiesel with diesel. That out of 100 grams of diesel, 95%, 95 grams will be diesel and 5 grams will be biodiesel. So, that is what we mean by 5% blending. So, this is something that we are going to do in the coming future. So this is biodiesel. Second one is bioethanol. In case of bioethanol, we largely get bioethanol from energy crops. We largely get this from energy crops, that these energy crops will undergo the process of fermentation, and after fermentation they will lead to the formation of bioethanol. And this bioethanol, it can be either blended with or it can be used to replace petrol. So India right now has a target of 20% blending. We want 20% blending of ethanol with petrol. Now, a question, and just think of an answer. All right, just think of a potential answer, that why are we thinking of only 5% blending with diesel and 20% blending with petrol? Why not 20% blending in both the cases, or why not 5% blending in both the cases? Why this difference between 5 and 20%? Just think of it. I'll give you the answer after this. Energy crops will have to be cultivated more. Good idea. Consumption ratio, great. Petrol is denser than diesel. Okay. We are already importing oil, insufficient domestic oil. Okay. The answer actually lies in the difficulty of production. I'll tell you problem. When it comes to the energy crops, in case of energy crops, what we have seen is uh, that production of energy crops is better in India altogether, and also easier. The quantity that we are getting, the quantity is also good enough. So that's why we have enough base that we can do 20% blending. But in case of oil seeds, first of all, we need very huge amount of oil seeds. The conversion ratio from oil seed to biodiesel is also not that great. So overall, that also hampers our prospects of how much blending we can do. And overall, the production of biodiesel as a process itself is a little more complex process as compared to the process of fermentation. Fermentation as a process is much easier to carry, and compared to that, esterification is not. So basically, it all boils down to how easy or difficult the entire process is. So that is the reason why we are actually at 5% right now in diesel, or why we are targeting 5% in diesel right now, and we are still able to target up to 20% in case of bioethanol. So this is the reason that why 5% biodiesel or diesel, 5% biodiesel, 95% diesel and 5% biodiesel, and here 20% bioethanol and 80% petrol. So that's why these two become the most important two primary sources of fuel. Now, when it comes to the advantages that we have with biodiesel and bioethanol, understand some basic points about what are the basic advantages that we have. So first advantage, when it comes to the advantage of biodiesel, is that it can reduce the exhaust emission by up to 80%. It does not produce any sulfur dioxide. Particulate matter can be reduced, that is what we call as PM 2.5 and PM 10 material can be reduced by up to 75%. And that's why overall we see that this is where this leads to a much lesser pollution as compared to what we see with normal diesel. Not only that, we even see that the flash point is at a higher temperature, that is 150 degrees Celsius, meaning that it is safer, that it will catch fire above 150 degrees Celsius as compared to petroleum diesel that has 70 degrees Celsius. And then one more automatic advantage that it gives is that it provides better lubricity as compared to diesel. So that's why with the right additives, biodiesel for the engines also will be much better as compared to petroleum diesel. So that is the reason why we see that there are all these aspects of the advantages that we have with biodiesel. Now, one more important topic from the perspective of Now, one more important topic from the perspective of the discussion of biodiesel is biodiesel that we can get from Jatropha. Now, Jatropha has been in use for almost like last, let's say, 20 odd years, or now almost 25 years. Understand why in news and why are we discussing about Jatropha altogether. So overall, when it comes to Jatropha, in case of Jatropha, what we see is that Jatropha basically are would bear fruits, as you can see in this picture, that it would bear fruits and it would have seeds, and these seeds can be used for biodiesel production. The good thing with Jatropha, that it does not need very specific conditions to grow. It can grow in soil which is less fertile. It can grow in soil even something that is alkaline. It can grow. It can be grown anywhere. I mean, you can grow it on the sides of the road, sides of the canals, railways, the boundaries of the farms. You can just grow anywhere. Does not need a lot of water to grow. It can grow in high rainfall areas and low rainfall areas as well. So there are all these advantages that jatropha has, growing it is basically much easier compared to any other crop. So then, almost I'm talking about early 2000s, that when for the first time government of India also understood that jatropha could be very useful in the future when we start with biodiesel production, they started promoting jatropha a lot. All right, and this is, I'm talking about the time of Atal Bihari Vajpayee government, when Dr. APJ Abdul Kalam was the president of India. They basically had started taking jatropha very seriously, and there was a lot of excitement about jatropha because of all these advantages that I just told you about. So then we saw that they started promoting it, so much so that Dr. APJ Abdul Kalam, he even started growing jatropha in the backyards of the Rashtrapati Bhavan. He just wanted to show to the people of the country, the farmers of the country, that look, it's so easy to grow jatropha that even somebody like me can grow jatropha in the backyards. So they wanted to promote jatropha as much as possible. And jatropha was being taken very seriously by the Atal Bihari Vajpayee government. Then after that, Dr. Manmohan Singh's government as well, we saw that jatropha was being taken very seriously. But then after this, we see that, and the first biofuel policy that we had back in 2009, it also had listed jatropha as one of the primary sources for biodiesel production. But then jatropha vanished. In these 10 years, the government was very excited. Even the UPSC was very excited. The state commissions were very excited. Everyone started asking questions from here also. In your prelims also, one question came in jatropha, and in the state examinations also, so many questions came from jatropha. But then all of a sudden, we see that the government forgets about jatropha, and UPSC also forgets about jatropha. So what happened? There was a certain issue that we saw with jatropha while trying to scale up our biodiesel production. In the early 2000s, we were not really producing any biodiesel. All right, so that's why it was not a concern, and we saw all the advantages. But then when we started with the large scale production, when we started to think of the commercial production, this is where we saw the problem with jatropha. And what are the problems? So there are a couple of problems that we see with jatropha. One, the growing time. The growing time can be up to 6 months. Up to 6 months. So basically, what we are saying is that it would take up to 6 months of time. It would take up to 6 months of time for for the jatropha seeds to be available before you can actually derive jatropha oil from there and then convert it into biodiesel. So you can say that the entire production perhaps would take up to 6 to 7 months of time. All right, up to 6 to 7 months of time. So that became one challenge, that if we want to scale up the production of biodiesel, jatropha can't be our primary source, because jatropha can't be grown very quickly as is the case with many of the other plants. So that's why that is not even a comparison. That was the one problem. There was another, and this another problem what with regards to the conversion ratio. Conversion ratio. So from the perspective of conversion ratio, what we basically saw was that if you have 100 kg of jatropha seeds, 100 kg of jatropha seeds basically would give you up to 25 kg of biodiesel. Now, this is a very poor ratio. All right, this is a very poor ratio. Generally speaking, we see that, and this is also up to 25 kg. Let me write up to 25 kg. It can be lesser than that as well. Now, generally speaking, we see that we get up to 40%, 45% production ratio, which is fine. Sometimes 30, 35%, which is still okay. But 25% was less. That first of all, you are getting this in like 6 to 7 months, and that too, you are getting in a much lesser quantity. So these two things made us realize that this can't be our primary source. Maybe an additional source. Maybe we can use it additionally apart from everything that we are using, but this cannot be our primary source. And hence, then we see that jatropha gets phased out. That slowly and steadily, every government stops talking about jatropha, and then ultimately we see that in the 2018 biofuel policy, they did not really even mention Jatropha a lot. Only here and there as additional sources it was mentioned, but not as a primary source. So that is where we see that Jatropha's story uh, takes a very a positive turn. I mean, very steep rise and a steep fall. So that is what we see with Jatropha. All right. So this was biodiesel, and then we have bioethanol. So in case of bioethanol, also we have certain similar advantages. That here also carbon monoxide emission can be reduced up to by 30%, volatile organic compounds by up to 50%, nitrogen oxides by up to 35%. So compared to petrol, we see that there are all these reductions that can happen. Again, there is no sulfur, so there is no sulfur dioxide, no particulate matter also. So particulate matter emissions also can be reduced. So that also becomes very, very crucial. And overall, we see that it can altogether reduce the greenhouse gas emission by up to 85%, which is huge. That up to 85% reduction in carbon dioxide emissions can be done with the help of bioethanol. Not only that, what we also see is that there is a particular kind of bioethanol on which there is a lot of research happening, called as cellulosic ethanol. Now, this cellulosic ethanol basically is the kind of bioethanol that we want to derive from cellulose. All right. Cellulosic ethanol basically is the kind of bioethanol. So this is bioethanol derived from cellulose. Now, what is the advantage here? What is the advantage? Where do you find cellulose? What is the source of cellulose? Quickly, somebody. What is the source of cellulose? Yeah, sugar, you can say. Leaves is correct. Plants, yes. The answer that I was looking for was plants. That any plant. What part of the plant? What part of the plant does have cellulose? What is it that is made of cellulose in every plant? The bark, that's correct. Wood, correct. The cell wall, right? The cell wall that you have in each and every cell of the plant cell wall is made of cellulose. So if we are able to use cellulose as a biofuel source, it simply means that every plant is open for you. Then we are not specifically looking for certain plants or certain crops which can act as a source, correct? So that's why cellulosic ethanol research that has been happening, and it's not a new research, has been going on for a while now, but it will definitely help us in increasing the sources and thus also adding to the energy capacity of the world. So that's why we see that there are all these advantages that bioethanol and biodiesel, etc., might be able to bring for us. The third source, okay, somebody has also asked for a break. Let's take a break after we are done with biofuels. All right. It perhaps will take me 15, 20 odd minutes more to complete everything related to biofuels. Let's take the break after that. So, biogas. Biogas is the third source. Now, this biogas is something that we get from the breakdown of organic matter in the absence of oxygen. The primary constituent in this biogas is methane. All right, largely it is made of methane, and apart from methane there are other gases. So in this way we see that there is biogas. So this is how biogas production happens, that you would collect all the waste. It could be animal waste, it could be agricultural waste, and all this waste will go into a slurry tank which goes into an anaerobic digester. So anaerobic, what is anaerobic? Absence of oxygen. Absence of oxygen. So in the absence of oxygen, there is a breakdown that is happening of the biological source or the biological remains, the agricultural waste or the animal waste. So what happens is that in limited supply of air, or rather absence of oxygen, the breakdown of this organic matter happens, which leads to the release of a lot of gases. leads to a release of a lot of gases, and these gases, they basically get collected in this gas holder. This is where you have the biogas, and this biogas then can be used for electricity production. You can use it for use it as a domestic fuel as well. So there are all these things that we can do. So in this manner, we derive biogas from here. At the same time, the leftover can also be useful. The leftover that we have from here can be used as a biofertilizer. So that also will be used. So there is a complete usage that we have of all the animal and the plant based waste that we had. And this is how biogas production happens. Just remember that in case of biogas also, largely biogas is made of methane. Primarily it is methane. Almost you can say up to 75%. Up to 75% of biogas is nothing but methane. And then apart from that, carbon dioxide and small amounts of other gases as well. So this is what biogas is. So there can be methane, hydrogen, carbon monoxide, and then after that carbon dioxide, hydrogen sulfide, moisture, all these things will be present in biogas. Now, in this case of biogas, first of all, we see that again there are certain advantages that biogas comes with. That obviously it is a renewable source of energy, it is a clean source of energy, easy production, easy usability, also local use. Because very easily you can just set up local biogas plants wherever you want. And in India, popularly these plants are also called as gobar gas plants. These are called as gobar gas plants. So biofuel gas plants, which can biogas plants, which can actually be set up anywhere that you want, portable or you can say local setups that we can create. In all these cases, we see that this is what will lead to gobar gas plants. So that's why all these things are possible with regards to biogas. There is one major thing that you should understand with biogas, that potentially it also has a positive impact on the environment, apart from the basics of what we have discussed, that yes, it is renewable, it is clean, we have good sources, easy production, less pollution. Fine, all these things are there, but there is one, indirectly there is one major advantage that biogas has for us, and this is how it has a positive impact on the climate. It tries to offset the amount of methane that we are releasing. So understand how, understand what happens here. Now, in general, what we are saying is that biogas basically has methane, and apart from methane, there are some of the other gases. So the fuel that we are using is methane. The combustion that will happen is of methane. Now, let's say the animal waste, let's say cow dung, all right, that we have cow dung, and this cow dung is being used for production of biogas. There are two things that could happen. Either you are using it for biogas production or you just leave it like that. But even if it is just left like that, what happens? It will start decomposing. Have you observed that even if there is some cow dung lying somewhere, in a week's time, maybe in 10 days time, it will completely decompose, right? Have you seen it? It's a trick question. You don't have to see and observe what's happening with it, but I know that you do have an understanding of what will happen in this particular scenario, that even if there is cow dung which is just lying around, it would simply decompose. But this natural decomposition of cow dung, when it happens, it will release methane into the atmosphere. All right, it will release methane into the atmosphere. But when you are using biogas as your fuel, what happens then is that you are not releasing methane anymore, but instead combustion of methane is happening. And what do we mean by combustion? Combustion is nothing but oxidation, the same chemical formula that we had seen. Right, the same chemical formula. So what is happening, that if you are burning methane, if you are making the combustion of methane happen, then in that case you basically are oxidizing it, meaning that methane is converted into carbon dioxide, and instead of releasing methane into the atmosphere, you are releasing carbon dioxide into the atmosphere. And we discussed about this in methane hydrates as well, that how carbon dioxide is not as potent as a greenhouse gas as compared to methane. that methane is much more dangerous as a greenhouse gas as compared to carbon dioxide. So if we have an option between releasing methane versus releasing carbon dioxide, let's choose carbon dioxide because it's less harmful as compared to methane. So that becomes one of the ways in which we are trying to offset the amount of methane that we are releasing into the atmosphere. So that's why this is an indirect way of thinking of a big advantage that biogas can have. So that's why all these gases that are being produced by biogas, by which will not be produced by biogas, this will have a very, very important impact. All right. So in this manner, we see that biogas will have a good advantage for the global climate change. Now, one topic which becomes very, very important for us is the National Policy on Biofuels of 2018. Now, this National Biofuel Policy has laid down certain objectives, and there are certain things that it is talking about. And these things become very, very crucial from the perspective of your examination as well. So, first and foremost, understand this policy, understand the basic crux of this policy. Now, this is not the first time that we had a biofuel policy. Before the 2018 policy, there was another policy back in 2009. But the 2009 policy, although it had targets, but there was no proper roadmap that was laid down for attaining these targets. And unfortunately, because of that, what we saw was that whatever targets were mentioned as a part of the 2009 policy, we could not really achieve it. For example, the targets that have been set by the 2018 biofuel policy were supposed to be completed by 2017 according to the 2009 biofuel policy. But in the absence of a clear cut roadmap, we could not really do anything. And in a manner it did not do very well. So that's why 2009 policy did not do what it was supposed to do. And then there was a revision done to the policy in 2018, and then the Ministry of New and Renewable Energy came out with a new policy on biofuel, and this was the 2018 biofuel policy. And what is the target that it keeps? It says that we have to have 20% blending of ethanol in petrol and 5% blending of biodiesel in diesel to be achieved by 2025. Now, this 2025 also was not the original number. Initially, it was supposed to be achieved by 2030. So in the 2018 biofuel policy, it first talked about 2030, but then in 2021, there was an amendment made to this policy, and 2030 was decreased to 2025. So this is a very aggressive positive step that was taken by the government, that they are saying that whatever we thought that we would achieve by 2030, we are going to achieve it by 2025 itself. So this is the change that they brought in the national biofuel policy, that from 2030 the target window was decreased to 2025. Now this time, as I told you, that this time it seems that they have a clearer roadmap. This time it seems like they have a clear cut roadmap to get to the required targets. Now, how exactly do all these roadmaps have been laid down? Just try to understand that. So first in, so if you see, there are these points: categorization, scope of raw material, protection to farmers, viability gap funding, and the boost to biodiesel production. So understand in the context of the examination, or rather in the context of the scheme, that what exactly is this policy talking about. So now when it comes to this national biofuel policy, so first and foremost what we see is that it talks about categorization. All right. So in what way is it talking about the categorization? For the first time, categorization into the first, second, and third generation of biofuel has been done. Until now, we had never done any classification. All right. So this first, second, third generation is often terms which are used in scientific research and papers, but government also adopted it, that they also have clearly defined what means, what for them means first generation, what is second generation, and what is third generation for them. So that's why we see that for the first time this is something that was done. So categorization basically into the first, second, and the third generation. All right. So when I say first, second, and third generation, these are very similar to what we had seen the last time as well. That first generation is food crop based, second generation is agricultural waste and the municipal waste and the crop residue, etc., non-edible plants, etc. And the third generation here is bio CNG. Now remember that in the Indian categorization, there is no mention initially of algae, although later in the 2021 amendment that they made, they also included seaweeds. They also included seaweeds that more or less you can say that they are algae. So although the production process is very different, so technically saying that it is third generation will not be completely correct. All right. So but seaweeds were also added to the list of all the things that can be used. So overall, this is basically what we have observed. So the first thing is categorization. The second thing is with regards to the scope of raw material. That first and foremost, we see that the raw material that we are using here, the raw material, there are multiple different types of raw material that can be used, and the government has clearly defined that these are the raw material to be used. So just understand how we have classified the raw material as well. First classification of raw material is on the basis of the sugar based crops. The sugar based crops where you have something like sugar cane, sugar beet, etc. All right, so sugar based crops. Then after that, they have also categorized starch based crops. So starch based crops are the ones which are good sources of carbohydrates. For example, corn has been included in the list. So this is something that we see. Then, so these are two primary sources: sugar based crops and starch based crops. Then after that, there are oil seeds as well. So we do see that they are also included here. So scope of raw material also talks about the oil seeds. So oil seeds like sunflower oil. Then after that, now there are some interesting categorizations as well. So for example, it also talks about agricultural waste. All right, agricultural waste, and it has also defined agricultural waste. For example, crop residue. Now this is where very important categorization also has been done, that instead that some of the staple crops have been kept out of the list. For example, let's say something like potato. Potato is a very good source of carbohydrate, so that's why it could become a very good source of biodiesel as well, sorry, biofuel production as well. But potato has been completely kept out because potato is a staple anywhere in the country. Wherever you go, in one form or the other, we are consuming potato, right? So that's why potato has been kept out of the scope of raw material, but rotten potato has been included. So that's why rotten potato has been mentioned here. So rotten potato means what? That the potato that might have gone into your samosas and dosas perhaps will not go there, and instead they'll be used for biodiesel production or biofuel production. Sorry, bioethanol production. So that may happen, and then at the same time, even rice. Rice also is a good source of carbohydrate, but again, rice is staple. We can't really let rice be used for biofuel production. Then in that case also, we see that broken rice has been included. Broken rice. All right, so broken rice, crop residue, rotten potato, all these things, they have been included. So agricultural waste has been included, then municipal waste has been included. Municipal waste has been included. Then after that, there is one more thing, and this is surplus crops. Surplus crops also has been included. For example, sometimes you might have heard this, that the production is so high sometimes that the farmers have to just throw away the vegetables that they have produced, because otherwise the supply is so much that they'll get nothing in the market. So that's why, because of that, the prices will be nothing for them and they will not gain anything. So in these scenarios, many times we see that the farmers simply just throw that away so that they can get better prices in the markets. So now what the government is saying here is that whatever surplus production you have, the surplus will be bought by the government and government will use it for biofuel production. So that's why surplus crops also has been included. And then there is one last raw material where we are talking about used cooking oil. Used cooking oil. All right. So used cooking oil meaning that so with cooking oil, the problem is that if you heat and reheat the cooking oil, it starts to lose its value, it starts to lose its nutritional value, and it starts to become much more worse for your health. All right. It will be very bad. It will start to develop bad cholesterol, bad fats, etc., and this will not be good for health. So that's why the cooking oil should not be used multiple times. It should be used, let's say, once or twice maybe, but high heating cooking oil multiple number of times can be dangerous. Now the government says that we can buy back the used cooking oil. Especially this is something that will be given to the restaurants, etc., that they shouldn't use the used cooking oil over and over again. There will be agencies all across, and these agencies will help them in getting back the used cooking oil. So that also will have a positive impact on the health. So that's why scope of raw material being perfectly defined was very, very important, and this is something that has been done in this particular biofuel policy. Then protection to farmers. Now, from the perspective of protection to farmers, we basically are talking about the surplus crops. That whatever be the surplus crops, the surplus will be bought by the government, and then in that case, they'll still get a good enough price for them in for from the perspective of whatever production they have done. Then there is a scope for viability gap funding. Now, viability gap funding basically is something that they have done to stress more on the biodiesel production. That they want that this basically has been given as a grant of rupees 5,000 crores for 6 years to boost advanced biodiesel production, meaning second generation biodiesel production. All right. So this is something that also has been kept. So overall, this is being given. Apart from that, we see that there, to boost this biodiesel production, there are tax incentives also that they are giving. So there are tax incentives also being given. So there are all these things, there are all these advantages that we see, so that they can help in better growth of this sector. Now, overall, that's why when we look at the expected benefits of the policy, there are multiple benefits that we might have. First of all, reduced import dependency. Because understand this, that once we start the blending, all right, once we start the blending, it would mean that we don't need to import as much oil as we do. So, for example, instead of 100 liters of petrol, we might start using 80 liters of petrol, and 20 liters will be domestic production of bioethanol. So, if we were importing 100 liters, now we will import 80 liters. Correct. So, that has an advantage, because if you are buying less, you are paying less. And if you are paying less, your forex reserves would increase. So, we would have a healthier economy altogether when we are able to reduce our import dependency. So that's why this will be a very, very major point, that it will help us it will help us in reducing the import dependency. All right. So, and this will help us in increasing the forex reserves. Increase the forex reserves. So this is what we will see, that overall, for example, let's say if we have 1 crore liters of E10 fuel, E10 means that when 10% blending has been done, it helps us in saving rupees a total of rupees 28 crores of forex reserves. All right, so that's why this is very, very important. And overall, what we see is that as we keep on increasing the targets, we'll see that the production is going to go up to like almost, let's say, up to 400, 500 liters to 250 liters we already have reached. So this will be able to help us in saving somewhere around 5,000 to 6,000 crore rupees in forex reserves. So that is very significant amount. Then of course it will lead to a cleaner environment as well. That uh, overall what we see is that this will be able to reduce the carbon dioxide emission. For example, the same E10, if we are again taking the same 1 crore liters of E10 fuel, it will be able to save some 28,000. All right, so not 28,000, 20,000. Sorry, it will be able to save 20,000 tons of carbon dioxide. 20,000 tons of carbon dioxide lesser. All right, so that's why we'll see that this will be another advantage. Then after that there will be health benefits, and this is mainly in the aspect of what we discussed about the used cooking oil. So in terms of used cooking oil, we'll see that this will be a very potential benefit. Then apart from that, we also have the solid waste management that can be done, that overall will be able to whatever municipal solid waste we produce, all this solid waste can also be used in the biofuel production. So that will also help us in also disposing the waste, because that also is a big menace for us. So we can save there, plus of course it will have a positive impact altogether. So that also is a major advantage. Then infrastructure investment in rural areas, that in this particular case what we see is that if we are able to invest in these areas. For example, let's say we are talking about an investment. If we have a plant which has the capacity of 100 kiloliters, then in that case an investment of rupees 800 crores is required. So which is a huge investment, and it can be set up anywhere. You are not restricted by location. So that's why you can set up the plants wherever you want, and that's why the government also has been planning that most of these setups will be done in the rural areas, so that rural economy can be helped. At the same time, it will also help in generation of jobs. That for example, the same, let's say if we are talking about 100 liters of production per day plant, then in that case it will be able to produce up to 1,200 jobs. Single such plant, one such plant will be able to produce up to 1,200 uh, 1,200 jobs extra. So that's why we see that there are other all these benefits as well. Apart from that, we see that there are additional income to the farmers as well. For example, that instead of burning the crop residues, these crop residues can be given to the government, and they can be given a price against this crop residue as well. Then apart from that, we discussed about the surplus also, that they will get better prices for the surplus crops, right? They'll also get better prices for the surplus crops as well. So overall we'll see that all these will also bring in additional benefits for the farmers, and farmers can also be helped. So overall, just understand that there are all these ways in which we'll see that there are expected benefits out of this policy. Now, one last thing before we take a break, and this is about the problems that we see with biofuels. We understand the advantages. We understand that it also has the same advantages as we had seen for all the other sources of energy. But understand one problem, and this problem is basically with regards to the food security. What we discussed is that most of the biofuel production still happens from the crop plants, correct? Still from the crops. Now, because crops are largely being used here, or rather the edible crops to be exact is being used here, it also means that it is going to have a competition with our food. That the industries might perhaps want that instead of food production, why not use this crop for biofuel production? And they might start to boost more of biofuel production as well. We do not want that to happen. So that's why there are certain problems that will happen because of that. First, for example, production of genetically modified crops will be encouraged, aimed at biofuel industry instead of food consumption. So this is perfectly possible that we might see that more of genetically modified crops which are qualitatively better as a biofuel than as food will be encouraged. So nutritional value of these kind of crops will start to decrease. So this will lead to decreased nutritional value. Then after that, there will be a decrease of food import capacity, especially in the poorest countries due to increase of prices. So what will happen is that we know that there are a lot of poor countries that are completely dependent on the food imports, that they don't have their own capacity to produce food, or maybe they live in areas which are not suitable enough for production of food. So then they import, and many of these are very poor countries, they import. So now what happens is that many of, let's say, countries like European countries or US or India, even India or China, all these countries, they would export food to these countries. Now what may also happen is, most of the times when the export happens, this is rice. Now we also know that rice can be used as a biofuel source. So maybe a country thinks that instead of providing that extra food to a poor country, why not use it for biofuel production? And if that happens, then the import capacity of these countries decrease, because there will be a price rise that will happen then. And these are already poor countries, they cannot afford a higher price. So their import capacity would decrease in such a case. So that is also something that can happen. So overall, what is happening in this particular scenario is that the price is increasing. All right, the price is increasing because the demand has increased. The demand has increased and the supply is constant. The supply is constant. So this is what happens, that when you have supply constant, demand increases, price will also automatically increase. Then biofuel production causes increase of food prices due to increasing demand for agricultural production, because we know that there is a competition between food and fuel. So overall what happens is that food prices will start to rise, because the same crops are supposed to be used. So here also the same thing is happening, that demand is rising, supply is constant, so price will rise. Then food and fuel crops compete for land and water resources, increasing their prices. So this is also one of the problems, that there will be a competition for resources, that if you have water, where do you use water? Where do you supply that water? So ultimately what is happening is that the resource price increases. The pressure on land resources also increases. So that's why the land prices also increase. So that's why resource cost increases, correct? Meaning that the production cost increases. Meaning that this will, of course, again lead to price rise, right? Then increase in demand for fuel crops may lead to lower food quality and diversity, threatening the nutrition of people. What basically this point tries to explain is that even if we want to try and increase our productivity, all right, even if we want to decrease our productivity, so overall what, okay, there is one small mistake that I've committed here. I should not write this, I just noticed. So when we are talking about the import capacity, we are basically saying that the supply has decreased, right? That the demand is constant. Let me write it again completely. The demand is constant. The country is still demanding the same amount of food. Demand is constant. The supply has decreased. Supply has decreased, and that's why price will increase. Right? This is what is happening here. All right. So increase in demand for food crops may lead to lower food quality and diversity, threatening the nutrition of people. Meaning that our focus will shift from quality of food to quantity of food, because we need more production so that we can support both food and fuel. So then it will naturally lead to less nutritional value in this particular food, in all these food crops. And then lastly, water availability for human consumption will be threatened. Now notice one thing, that these crops that we are using as a source of biofuel, these are not crops that use less water. Correct? Name, okay, again an exercise for you. Name two or three plants or two or three crops that you know they use the huge amount of water. I mean, the most amount of water. Yes, paddy or rice, correct. What else? So rice we know, carbohydrate source, so of course can be used. Yes, sugarcane, jute, rice, but jute is not a source here, but sugarcane is correct. So sugarcane is a primary source. So sugarcane also we know that it needs a lot of water for its growing. So that's correct. All right. So main two crops, rice and sugarcane, they take a lot of water. They consume a lot of water for their production. So then in that case, it makes it difficult for getting that much of water that will be required for this kind of production. So obviously, the pressure on water resources will also increase. So there are all these problems. There are all these problems that we have with biofuel production as well. So these are some of the areas of issues that we have. We discuss about the advantages and all the other points, but at the same time also understand the issues that we have with all these things. So let's take a break here. But if you have any question with regards to whatever we have discussed until now, any question if you have with regards to what we just discussed. Full form of KLPD. KLPD is kiloliters per day. All right, kiloliters per day. So when we say 100 KLPD, it is 100 kiloliters per day, the production value. When when will we take a break? Just we are just about to take a break. All right, it's just after this question answer session, we'll take a break. Cleaner environment 1 crores E10. Please re-explain. So what I am saying is that this E10 means that when you have done 10% blending, all right, 10% blending is called as E10. Similarly, when we say E20, E20 is 20% blending. So this is a nomenclature that we use for how much of blending is done. So what I'm saying is that if you have 1 crore liters, all right, I should have written liters, that is missing here. That's why you might have gotten confused. 1 crore liters of E10 fuel will help us save 28 crores rupees of foreign reserves. All right. Meaning basically if we are dealing in dollars, for example. So what we generally see is that annual production is in the range of, let's say, 200 to 250 crore liters. So then multiply it with this number, so you'll see that almost we can save up to 5,000 crore rupees equivalent of foreign reserves when we are moving to E10 or E20 fuel. What is the mechanism in flashing geothermal power plant? So flashing basically is when you are going from very high pressure to normal pressure. So this kind of a pressure difference, what it will do is that the water that was in the liquid state, it will quickly convert into its gaseous state when it comes to normal pressure, because this water is at, like, let's say 150 degrees Celsius. So 150 degrees Celsius, it should, under normal circumstances, it should exist as steam. But because of because of the fact that we are using high pressure, it was still in the liquid state. In the flash tank you have normal pressure. So as soon as this liquid water comes to normal pressure, it will quickly convert into steam. That is called as flashing. Can we make notes or refer to annotations? I'm writing everything necessary. So, and rest of things are just stories. So even if you don't write or make notes from those stories, doesn't matter. Anything extra that is important for your exam, I'm writing on the screen itself. So just use the annotations. All right. So I think these were some of these doubts that we had. So let's take a break here and let's be back. I think there will be a new link for you after this. And then after that, we'll move on to our next topic. All right. So let's take a break here.